This is Christopher Sernaque hosting episode 22 of season 5 of the Current Topics in Science podcast. This podcast will address breaking scientific news in light of the origins debate and host interviews with scientists. Today we'll be interviewing Dr. Ben Clausen on the fine-tuning of the universe and life. This podcast is available on the following platforms: iTunes, Stitcher, Google Podcasts, Spotify, and iHeartRadio. Video recordings of the podcast will be uploaded to YouTube. Enjoy the podcast. Today on Current Topics in Science, we have the honor of hosting Dr. Ben Clausen. Dr. Clausen obtained his bachelor degree in physics and math from Union College at Lincoln, Nebraska. He's worked as a high school math and science teacher and a technical assistant for seismic data processing. He has a master's degree in geology from Loma Linda University that he obtained while doing additional studies from the University of California, Riverside. He also has a PhD in nuclear physics from the University of Colorado, Boulder. Dr. Clausen has also held positions as a research associate at the Institute of Nuclear and Particle Physics. He also served at the Department of Physics at the University of Virginia, where he served as an adjunct assistant professor of physics at the Department of Physics. He's also served at La Sierra University, Riverside, and he's currently an adjunct professor of the Department of Earth and Biological Sciences at Loma Linda University. He's also a senior research scientist for the Geoscience Research Institute, and he's authored numerous abstracts and technical papers in nuclear physics and geology. And now, without further ado, good afternoon, Dr. Clausen. How was your day, and how are you doing?
Thank you very much. It's a pleasure to be on your show, and I'm very pleased to be talking to you. How am I doing? I just got back from several weeks in Peru and Colombia, where we were doing geology research in Peru and then doing some lab research at the National University of Colombia. We've been working in Peru for the past 13 years, studying large-scale geology issues there, like plate tectonics and radiometric dating, and how they relate to the sequence of events in the geologic column. So we're excited to be working on that. We've developed some very good interactions in the scientific community, including working at national laboratories. And we've made lots of good friends in the scientific community and been able to develop a great deal of respect for what geologists are doing as they are working in some of these areas that we're excited about.
Thank you for sharing those experiences, Dr. Clausen. And we are likewise happy to have you on the podcast. And since this is Current Topics in Science, let's quickly take a look at this week's current topic. So today we're going to be looking at an article called Possible Fifth Force of the Nature Found. The article says, over the years, humans have come up with 4 forces that can be used to describe every single interaction in the physical world. They're gravity, electromagnetism, the weak nuclear force that causes particle decay, and the strong nuclear force that binds quarks into atoms. Together, these have become the standard model of particle physics, but the existence of dark matter makes this model seem incomplete. Surely there must be another force, or forces, that explain both its existence and the reason for its darkness. Hungarian scientists from the Atomi Nuclear Research Institute, led by Professor Attila, and I believe I'm pronouncing this correctly, Sernaque, believe that they found evidence of a fifth force of nature. While monitoring an excited helium atom's decay, they observed it emitting light, which is not unusual. What is unusual is that the particles split at a precise angle of 115 degrees, as though they were knocked off course by some invisible force. So Dr. Clausen, what do you think of this new possible fundamental force of the universe? Does it indicate design to you? And if so, why?
I've been interested in the fifth force or a fifth force for a number of years. I remember when I graduated from University of Colorado back in the 1980s that there was quite a bit of discussion about it. And I tried to follow it then. This one that you're referring to is another example of somebody suggesting a fifth force. First of all, we'll go over the four forces that people are familiar with and that you mentioned. Gravity is the easiest one. It's what holds us to the earth, and it's what makes the earth go around the sun. The second one that everybody's familiar with is the electromagnetic force that governs most everything else that we usually think about: electricity, magnetism, light, what it is that holds the atoms together. It's important for chemistry, biology, and so forth. It's an attractive force as well as a repulsive force. Everybody's heard the phrase likes attract, opposites repel, and so forth. So those are the two forces that everybody's familiar with. A third force that in general people are not so familiar with is the strong force. However, when you think about it, if you say likes repel and opposites attract, what is it that holds the nucleus of the atom together? Because you have protons and neutrons in the nucleus. So if the protons all have the same charge, why aren't they all repelled? So the strong force is what holds those protons together in the nucleus. And it's stronger than the other forces, but only at very short distances. At long distances, the force quickly fades away. The fourth force is probably the most complicated one and the hardest to understand. It's the weak force. It governs some radioactive decay, beta decay. For example, protons turning into neutrons or neutrons turning into protons. And it's responsible for something like carbon-14 decay. But it has a shorter range than the strong force. So those are the four forces that are relatively well known. But for quite a while, physicists have been looking for the possibility of other forces besides those four forces. And as you mentioned, they are looking for ways to understand anomalies that you find in nature: dark matter, dark energy, the expansion of the universe, and so forth. The one that I was familiar with back in the 1980s had to do with, well, it was related to Einstein's The General Theory of Relativity. And it has to do with, is gravitational mass the same as inertial mass? So if you drop a feather and a lead ball, do they hit the ground at the same time? And so you would think, well, the lead ball is attracted much more strongly to the earth, so it would hit first. But then on the other hand, you would realize that the lead ball has more inertia and it's hard to get it to move. And so maybe it wouldn't move quite so fast. And those two seem to balance each other out. And in general, something heavy and something light would hit the earth at the same time. And so then they found a new force in the 1980s, or they thought they did, where these two forces weren't exactly the same. And there was a lot of analysis on it, and it didn't seem to work out quite so well. More recently, maybe about 20 years ago, they found what they call a chameleon force or a chameleon particle, long range attractive, but then also that one the evidence for it didn't seem to pan out. The one you're talking about, this new X17 particle, they've called it protophobic. Protons are scared of each other, I guess you could say. And it's talking about helium decay. They also talked about lithium and beryllium and maybe solving the problem of dark matter or understanding it better. That one, it's an interesting idea. It was first suggested in 2015, 2016, and new observations were made in 2019. It's not clear that one's working out very well either. There's others that just in the last couple of years, 2 years ago at Fermilab, they did these muon experiments with particles that are kind of like electrons, but much more massive. And the suggestion was that maybe they were sensitive to something else besides the four forces. So some work has been done on that, but it's not clear that that's going to work out either. So there's various forces that have been looked at. People are very excited about them. If a fifth force was found, it would get a Nobel Prize in physics, I'm sure. So then you had a question, what does that say about fine tuning? It does seem like the forces of nature are finely tuned to be what they are, to get the universe to work the way it does. If you found an additional force, would that mess up the fine tuning of the others? Well, probably any additional force is going to be much weaker than the others, or else we would have observed it already. So it may have something to say about fine-tuning, but it's not quite clear. However, it does seem that the forces are finely tuned so that life is possible.
Thank you for covering that current topic, Dr. Clausen, on the fundamental physics of the universe. And speaking of physics, from your own field of nuclear physics, do you see the evidence of God's design? And if you do, may you please share it.
I have a lot of fun with nuclear physics. I spent 15 years of my life doing nuclear physics. Then I got into geology. I tell people it was a midlife crisis where I kind of switched because I enjoy being outside and hiking as well. But both the physics and the geology are fun. But to tell you the truth, the more I study, the more I realize I don't know. And I could give you various examples. In the physics area, I give a talk about God and the new physics, where I talk a little bit about relativity and quantum mechanics, and realizing that physics can explain amazing things, but it also has its limitations. And I'll give you 3 examples. One is determinism, another is objectivity, and another is reductionism. In general, science is seen to be deterministic, where every effect has a cause. And that's what we expect in science. That's what we expect in physics. And in general, that works really well. But there are little pieces of the new physics in quantum mechanics where you get effects that can't be directly tied to a cause. And an example that's given is with radioactivity, you can figure out what the half-life is. And so on average, you know how long it takes for half of the radioactive particles to decay, something like uranium atoms. You know how long it would take for half of them to decay. So in the big sense, it's very deterministic. But on the small scale, you can't predict exactly which of the uranium atoms is going to decay. So on the big scale, you have an effect that you can trace back to a cause. But on the individual scale, you lose that determinism just a little bit. Another example of where I can see some of the limitations of science is objectivity. And this, again, with quantum mechanics, and I'll use the example of Schrodinger's cat, where this is a famous little story. It's one my daughter doesn't like too well because she likes cats. But the story is, if you put a cat in a box and you put some radioactive material in there, let's say uranium, and the uranium decays, it sets off a Geiger counter. The Geiger counter trips a hammer breaks a bottle of cyanide, and it kills the cat. However, according to this thought experiment that Schrodinger came up with, the uranium atom is both decayed and undecayed at the same time. And it's not until the observer pokes a hole in the box to look inside that it's suddenly one or the other. So if the uranium atom is both at the same time, does that mean that the cat is both alive and dead at the same time? And it depends on the observer. So generally, science is thought to be objective. It's independent of the observer. Whether you're looking at it or not, it's going to do the same thing. But there seems to be just a little piece of quantum mechanics where that objectivity is lost. And Schrodinger gave this example of the cat that's both alive and dead at the same time until it's observed by a human observer. So there's a couple examples of the limitations of science, the limitations of physics. Not to say that physics doesn't do spectacular things. I mean, all of our engineering feats that we look at, pretty much all of them are related to physics type of things or chemistry. But there are some limitations to what science can do, limitations in determinism and limitations in objectivity. It does seem that as I look at the physical constants, that these constants are fine-tuned to make life possible. And that's fairly well recognized by everybody. People give various explanations for why they're fine-tuned that way. One is the anthropic principle that if they weren't fine-tuned for life to be possible, we wouldn't be here to observe it. So obviously, they have to be fine-tuned for life. But in general, I found that the creator, can be often beyond my understanding. And there's paradoxes that I don't understand. And so when I look at the Bible, I see it says the same thing. God says, my ways are higher than your ways. So there's a lot that I don't understand. So yeah, I get excited by doing physics stuff and see the amazing way that all the laws of nature work together.
Thank you for answering that, Dr. Clausen. And you had mentioned this concept of design and fine-tuning in your last answer. And so can you please explain what exactly does fine-tuning mean? And can you please provide a few examples of fine-tuning?
So we talked a little bit about that already, and so I'll expand on it a little bit. So yes, the forces of nature seem to be fine-tuned to give the range of elements in the chemist's periodic table. And here's an example of how they have to be fine-tuned to give that big range of elements from 1 proton up to 92 protons and beyond. So from high school science classes, you may remember that opposites attract, like electrons and protons in the atom. So that's due to the electromagnetic force that we already talked about. But again, I'll emphasize the nucleus of the atom is full of protons. If like charges repel, why doesn't the nucleus and all the protons fly apart? It must be because of an even stronger force, and it's just called the strong force for lack of a better name. So we already talked about that. Now, what does that say? The electromagnetic force and the strong force have to be finely tuned. If one of them's too strong, you get one end of the periodic table that doesn't work. If it's too weak, you get the other end that doesn't work. So for example, if the electromagnetic force were too strong, or there weren't any strong force, the only atoms would be hydrogen atoms. Because if you have 2 protons, like in helium, they'd repel. And so you can't have the electromagnetic force too strong. On the other hand, if the electromagnetic force were weaker, or conversely, if the strong force were stronger, then there would only be the heavier elements like gold and lead and even carbon and oxygen. So if you had too strong a force, you'd have all of these protons and neutrons clumping together, and you wouldn't have any single protons all by themselves. So you wouldn't have any hydrogen. So on the one hand, you need to have the light ones like hydrogen, but you also need to have the heavier ones like oxygen and carbon for life to be possible. So that's one of several examples of fine-tuning that I find to be quite useful as I think about why are the laws of the universe set up the way they are, and why are the constants set up the way they are?
So, Dr. Clausen, it sounds like you're saying that the universe has finely tuned settings. And along those same lines, would you say that the Earth is designed for life? What about the Earth would indicate to you that it itself was designed for life?
Again, that seems to be generally accepted by everybody, that the Earth is specifically designed for life. There's a science book that came out a few years ago by Peter Ward and Donald Brownlee. The book is entitled Rare Earth: Why Complex Life is Uncommon in the Universe. And that's related to the search for extraterrestrial intelligence. Why isn't that we haven't found other intelligences, alien intelligences? And one suggestion is, well, the right kind of Earths for life are not very common. So Ward and Brownlee in their book suggest some criteria that are not necessary for life. It needs to be a terrestrial planet. In other words, a planet with a landmass. It can't just be a gaseous planet like some of the planets in our solar system are. It needs to be a terrestrial planet with plate tectonics, where the plates move around, where the elements necessary for life, the compounds necessary for life, can be recycled back to the surface of the Earth, and the need for oxygen. It needs a large moon. Our moon makes it possible for tides to exist, so the water doesn't become stagnant. You need a magnetic field to protect the Earth from cosmic rays. You need a gas giant like Jupiter for protection from things that are floating around in space. And you need an orbit, the Earth's orbit, in a zone that's habitable. So if it's too close to the sun, it's too hot. If it's too far away from the sun, it's too cold. And you have to have the right kind of a star as well. So there's a number of authors who have written about this. Paul Davies has several books that I've enjoyed reading. One of his is God and the New Physics, that I've kind of taken some of my talks after that. But he also has one entitled The Goldilocks Enigma. Why is it just right for life here on this earth? So if your listeners are interested, I would suggest that one possible book they could read is Paul Davies' book that talks about design. There are specific examples. We have air and water on this earth that make life possible. If air had too much oxygen, we'd end up having fires all the time. If it had too little oxygen, then there wouldn't be sufficient for respiration for life to exist. So air has unique properties. Air is about 20% oxygen, about 80% nitrogen, plus a few other gases as well. Water also has unique properties. You need lots of water for various reasons. One is its specific heat, means how much heat can it store. So if you're out in the desert, it can get very hot during the day and very cold at night. But if you're close to the ocean or you're close to a large lake, you don't have such wide fluctuations in temperature because water holds the heat. And so it keeps it from getting too hot in the day or too cold at night. One other example is how water expands when it freezes. Most things, when they go from a liquid to a solid, contract, whereas water expands just a little bit, which means that frozen water has a density that is less than liquid water. So frozen water, ice, floats instead of sinking to the bottom. So that wouldn't work very well if whenever water freezes, it sinks to the bottom, and then you eventually build up all that frozen water at the bottom of the ocean instead of having it floating around. So several examples of how the earth is designed for life. So the question is that design from an intelligent source, or is it just because there's millions and billions of planets out there and we just happen to be on the right one where it's possible? So there's all kinds of discussion about that, but everybody pretty much agrees that the earth is specifically designed for life.
Dr. Clausen, we've now come to our final question. And with the designer making the universe and earth for life, it would seem to suggest that they're benevolent. Have you found that to be true in your own experience as both a Seventh-day Adventist Christian and a scientist? How has God changed your life?
I see God in nature, but I can also understand why some people are reticent to say that nature leads to God. So it's made a big difference in my life. But I want to recognize that some people would disagree with some of my arguments, and that there are complications with some of those arguments. So I'll get to your question in a minute, but let me give a couple examples of cautions with the design argument. As far as the earth being designed for life, one of the comments that I mentioned was plate tectonics. Plate tectonics seems to be necessary for life to exist here on the earth. But plate tectonics assumes long ages. So some creationists would be uncomfortable with the idea of long ages. So that's a caution in using that kind of an argument. Another argument, the fine-tuning argument that we talked about, some of the fine-tuning arguments assume the Big Bang, that the Big Bang occurred a long time ago and got things going. One other caution as far as intelligent design for life. I personally believe that God designed life. However, I do struggle with the question of what appears to be evil intelligent design. Now, I'm not a biologist, and I've heard arguments for the design of the evil things we see in nature, but that is something that one needs to keep in mind. And this especially was a difficulty for Charles Darwin, where there's a famous quote. He says, "I cannot persuade myself that a beneficent and omnipotent God would have designedly created the ichneumon wasp with the express intention of their feeding within the living bodies of caterpillars. So it seems like the wasp system was designed to lay eggs in a caterpillar that hatched into larvae that ate the caterpillar from the inside out. And they were designed to eat the non-essential part of the caterpillar first. So did God design these parasites? People have answers for that, and I think some of the answers are quite good. But on the other hand, that does present a question, the theodicy issue. Why is there evil if we serve a good and a powerful God? And I was asked this when I was working on nuclear physics experiments in Russia 30 years ago. Why is it that we see all that evil? I am a strong believer in God and the Bible. So how is it that God has changed my life? I feel that as I look at Jesus, the example of his life, I see there a character, I see a person that I want to be like. And so he has changed my life as I have studied his life to see how he lived, how he related to people. And I want to use that same approach myself as I relate to people and as I live my life. And I use his example in how I go about treating people. There is a quote by an author that I've really appreciated, Madeleine L'Engle, that was pointed out to me by my daughter. Madeleine L'Engle says, "We draw people to Christ, not by loudly discrediting what they believe, by telling them how wrong they are and how right we are, but by showing them a light that is so lovely that they want with all their hearts to know the source of it." So I'm anxious to share what I find in science, but in the process of doing that, I'm not out to tell other people how wrong they are and how right I am. Instead, what I prefer to do is to offer them something better, to offer them friendship, to offer them a loving, a powerful and a loving God. And I see that that's what Christ did. Christ didn't get into arguments with people. At times, he was asked difficult questions, and he was able to answer in ways people tried to trick him into giving answers that they wanted. But he was wise. He knew how to respond to those answers. And I find that his approach has made a big difference in my life. So, how has God changed my life? I would say that God has changed my life through the example of Jesus Christ and the difference that it makes in my life every day.
Dr. Clausen, thank you very much for your time. It was an absolute joy. And to our listeners, thank you very much for taking the time to learn with us on current topics in science, where scientific discoveries are examined in light of the origins issue. You can find Dr. Clausen's biographical information, his technical papers, and his various projects in the description, along with a link to the Christ Jesus Ministries merch store. Please share and subscribe to Current Topics in Science. It's available on iTunes, Stitcher, Google Podcasts, Spotify, and iHeartRadio. Thanks again for listening, and remember, the truth saves.